Okay, today we are going to be doing something a little bit different. We're still going to be talking about box and whisker plots, but we are going to just look at how do we analyze it? How do we interpret the data? When I see a box plot, how do I make sense of what those numbers are trying to tell me? So every graph that we've talked about is just a little bit different, but overall what we're doing with graphs is we're just trying to make sense of data. We're trying to put it in a way that is organized and so that we can make sense of it. And when something is visual, it helps us to understand what the numbers are trying to tell us. So let's review a couple of things. So the first thing I want to review is the vocabulary. So what are some of the terms that we talked about on Monday? Because when we're analyzing it and when we're being asked questions about a box plot and we're trying to interpret what it means, it's important to understand what kind of lingo and what kind of vocabulary we're dealing with. So let's just review. So remember that this right here, and we'll just pink's good. Okay, so this number right here is the very lowest number. You will either hear it called the minimum or you'll see it called the lower extreme. So those are two things that you might see. On the other end, we have our maximum or the upper extreme, and that is our highest number. Okay, so we have our lowest and our highest, and then everything in between. So this line right here, that is the median of your lower half of data, and that you will see either called the Q1 or the lower quartile. This number right here, this line that separates your box into two pieces, that is called the median, that or the Q2, and it will be the median of your whole set of data. So if somebody asks you, hey, what's the median or what's the number in the middle, then you will know that you're going to look for that line. You're going to look for the line inside the box, and that is going to represent the median. This right here is going to be the upper quartile or Q3. And this whole entire box, we talked about this on Monday, this is called the interquartile range. So you have your Q2 and your Q3 that represent your interquartile range. So just as a review too, I want you guys to remember that when we are creating a box plot, basically what we're doing is we're separating a long line of data into 4 equal groups. So that's really important to understand. And there are going to be some sets where it's not exact, but they're approximately 4 equal quarters. So let's take a look at what that looks like. So this is important to understand when we are analyzing the data so that we know that from here to here is our first quarter. From here to here is our second quarter. From here to here is our third quarter. And from here to here is our fourth quarter. So we've taken our whole set from our lowest number to our highest number, and we have separated it into 4 equal groups. Now, that doesn't mean that all of the boxes and the whiskers are going to be the same length. We're going to talk about that here in just a minute, but it means that the numbers have been separated into 4 equal groups. So you will have approximately the same amount of numbers in your first, second, third, and fourth quarters. So this box right here, this first quarter, and I'm going to erase the lines here. Okay, so this first, from our minimum or our lower extreme up to the first part of our box or the Q1, this represents 25% or 1/4 of our data. From this line to the median is our next quarter, which is 25%. And then from the median to Q3, our upper quartile, that is also 25%. And from here to here, from the end of our box to our upper extreme, over the very highest number, is also 25%. So remember back when we did percentages, we know that for 25% is going to equal a grand total of, think of it in your mind while I'm drawing this, this is 100%, which is our whole set. 100% is the whole. Okay, so all 4 quarters will equal the whole range of data. Okay, so if I wanted to know what do these 2 quartiles equal, what percentage? 25 plus 25 is 50%. If I wanted to know what these 3 equaled, then that's 25% plus 25% plus 25%. So these 3 boxes or these 3 quarters would equal 75% of my data. And when we start to analyze it and we start to do some problems, you'll understand why that's important to know. You need to understand that every section or every quartile represents 25% of your data. Because remember when we created our median, or we ordered them from least to greatest, we cut our numbers in half, and then we cut those halves in half, and then we created 4 equal parts. And we know that 1/4 of a whole is the same as a quarter, or 25%. So just make sure you keep that in mind. All right, moving on. Okay, now this box right here, you can add up the 225%, but this box, remember, it is called your interquartile range, or the IQR, interquartile range. And this represents half of your data. This is the middle half of your data. So you have 2 boxes that are each 25%, and just keep that in mind that when you look at the box, that's half of your set. That's half of your data split up into 2 25%. All right. So now let's talk about what the length of the box means. So you will notice here I have 2 different box plots that look very different. Even though I have 4 sections, I have 4 quarters in each of them. So they're both box plots, but you'll notice that the length of each quartile is different. And so that means something different. So let's analyze that. So here I have 1, 2, 3, 4 quarters. My second box has 1, 2, 3, 4 quarters. So they each equal 25%, which 4 of them put together equals 100% of my data. So why is it that this box has a longer second quartile than this one? So you'll notice that this one right here is much longer than this one, even though they both represent the second quarter of the data. So let's take a look at what that means. So this guy right here, it starts at, we'll say, we're just gonna have to estimate since it's not exactly on a tick mark. This is about probably 32. So it goes from 32 to 40. So we have a range of 8 numbers. This box up here starts at 30 and it ends at about, we'll say, 40, 43, or no, sorry, past 45. It will go probably about 47, we'll say, so 30 to 47. So what that means is that this right here has a shorter range. So there's not as big of a span of numbers. So when you see a longer box, what that means is that you have a larger range. So the shorter the box, so this guy right here is shorter, you only have an 8 number span. So from 32 to 40. This one starts at 30 and ends at about 40. What do we estimate? 48. Okay, so we've got about an 18 number range. So in this second quarter of data in this green box, you just have a larger range of data. So the shorter the box, the smaller the range. The longer the box, the larger the range of data. So that's what the box length represents. And also with the whiskers. So from here to here, we have a larger range from our lowest number up to the next quartile. So that's really what the length of the box represents, is just how big is the range of numbers in each of those quarters. Moving on. And let's erase. Okay. So now let's practice analyzing. So here we have a box plot that represents the time spent reading last night in Mr. Jacobs' class. So the first quartile, or the lowest number actually, is 25 minutes. The highest amount is 70 minutes. So that's our range, is from 25 to 70. And we've broken that up into 4 equal groups. Okay. So question 1. What percentage of students read under 40 minutes? Okay, so my first thing I'm going to do is I'm going to identify where 40 is at. 40 is right here. And it wants to know what percentage of students read under that. So that's going to be this whole group right here. And what percentage does each quartile represent? Well, it represents 25%. So the answer to this question is, how many students read below 40 minutes? 25% of the students read under 40 minutes. Next question. What percentage of students read between 40 and 55? So let's identify the range that's asking us. So here's 40 and here's 55. So there's two different sections here in that range of numbers. So we have 25% here, and we have 25% here. And that's ugly, and that's okay. So we have two sections. Each of them are 25%. When I add those together, or when I combine them together, I get 50%. So the answer to this, so what percentage of students read between 40 and 55? Well, it's 50%. And you remember when I talked about the interquartile range, that box is always 50%. So if you have a range, it's asking you for just the box, it's always going to be 50% if it's asking for the whole box, because that's two sections of 25%. All right, moving on. Erase. Question 3. What percentage of students read more than 40 minutes? So again, let's identify where the 40-minute mark is. And it wants to know what percentage of students read above that. So I'm going to go from the 40 line all the way up to the highest number. So how many sections of 25 are there in that range of data? Well, we have 1 that represents 25%. And I really wish I didn't have to do this with my fingers, but it is what it is, kids. So here's another section that's 25%. And here's my last section that's also 25%. So when I add all those 25% together, what percentage do I get? 25, 50, 75. Just remember back to second grade when you were learning how to count money and how you were counting quarters. So we have 3 quarters, 25%. That's 75%. So what percentage read more than 40 minutes? Well, that is 75%. You got it. All right. So now that we've had some practice talking about percentages, let's have you guys try one on your own. Okay. Okay, this one is not dealing with percentages, but I still want you, in fact, from here on out, if you would just push pause after the question is stated and try to answer them on your own. We're going to see how well you can try to interpret on your own, and then check yourself when I go over it with you. So the first question here on this new box plot, which is dealing with SAT math scores, what was the highest score on the SAT? So go ahead and try it on your own, and then we'll go over it together. Okay, so the highest score would be your upper extreme. It's going to be the highest number in your set of data. So what's the highest number? Well, it's going to be this number all the way up here. So what was the highest score? Well, it's going to be right here, which is 720. So whoever scored 720 was the highest scoring person on the SAT. Okay, let's try another one. Okay, so question 2, what is the median of the SAT scores? Try it on your own and then unpause. Okay, so the median, remember, is this line right here in the middle of the box. So I'm going to identify the line right there that cuts my whole data in half. So the median is this line right here, and the median is 500. That is the number that is exactly in the middle of this set of data. All right, let's move on to the next one and try this one on your own. Question 3. I guess that one was the same. Okay, question 4. What is the value of the upper quartile? And I'm going to give you a little hint here. The upper quartile, remember, is the line at the very last line in your box. So you're just looking for the value that represents that line. So what is the value of the upper quartile? Go ahead and push pause and try it on your own. Okay, so the upper quartile is going to be this guy right here. So this represents the upper quartile, or Q3. And remember, this is the lower quartile, or Q1. And so the upper quartile is going to be represented by 560. So the value of the upper quartile is 560. All right, moving on. We have just a few more left, and then you guys are going to try some on your own today. So here we have a different box plot. So it says the dot plot represents the weights of several types of cellular phones. What percent of phones weigh at least 5 ounces? That means that the lowest that it could be is 5, but it could also be more than that. So go ahead and push pause and try it on your own. Okay, let's analyze this together. So I'm going to identify 5 ounces, which is right here. And then it wants to know what percent of phones weigh at least. So that word at least means that this is going to be the lowest that it could be, but then everything higher than that. So what percent? Well, here's a 25%, and here is a 25%. So add those together, and the percentage of phones that weigh at least that is going to be 50%, because it's two sections of 25 put together. So 50% of the phones weigh at least 5 ounces. All right. We have 2 more left, and then you guys are going to try some on your own. So remember, you're going to get the most out of these videos when you try and you actually go along with me. All right. What is the difference between the interquartile ranges of box plot A and box plot B? So it's asking us, so the range is starting from here and ending here. So I will just tell you that the range of box plot A, of the interquartile range, which is the box, it's from 40 to 80. So I would subtract those numbers, and the range, or the amount of numbers in that box, is 40 data points. And then for this one, let's even get crazy and use a different color. So for this guy, we start at 50 and we end at 75. So our range from here to here is going to be 25. Okay, so it wants to know what's the difference between those two. So go ahead and try it out, push pause, and see if you can find the difference. Remember, difference means we subtract. Okay, let's do this one together. So 40 minus 25, and the way that I would do this in my head is just going 40 minus 20, which is 20, and then subtracting 5 more, and that would give me 15. So the difference between these two is 15. I know that one was a little bit more involved, but really what we're doing is we're just comparing, we're analyzing, and once you know what every one of these sections represents, then an understanding that from here to here is this range of numbers, then we can really do anything. So just keep that in mind. And erase. Okay, this is our last one. So which box plot has the greatest median? So you need to identify the median on both of them and then try to figure out which one is the most. So go ahead and push pause and try this one out on your own. Okay, so the median, remember, is the line right here in the middle. So the median of March is 70, and the median of April, looks like these are counting by ones. Yep, so 70, 71, 72, 73. So they're just actually one apart from each other. So April is 71, March is 70, just 70. So this one right here is greater than this one. So hopefully that helps. Just if you need to review the vocabulary, because sometimes it's going to ask you what's the lower quartile, or what's Q1, what is the value of your upper quartile, what's Q3. So make sure that you understand those different vocabulary terms, because it might just ask you the value of one of those vocabulary terms. But also just remember that every section is 25%. And it might ask you for multiple sections added together, but we can add 25s very easily. 25, 50, 75, 100. So just keep that in mind. And if you have any questions, please reach out and let us know. Good luck, you guys.